Hello students, welcome to my channel Elite Maths class. Today's topic is matrices of class 12. It is actually the continuation of the previous chapter determinants, and some concepts are almost same as in the determinant. It is also in the matrices. For example, the rows and columns, which are already discussed in my first video of the determinants. So if you are watching first time, you first go through the link given in the description box for the first video of the determinants. Now, what are the differences and what are the similarities between matrix and a determinant? Before that, first see what is a matrix. Matrix is nothing but an arrangement. Remember that matrix is nothing but an arrangement. That is, we have to arrange some elements, some numbers in some way. That structure or that arrangement or that array is called a matrix. But what is a determinant? The determinant is also an arrangement of numbers or some elements, but a determinant having a value. Every determinant having its value. This is the main difference between a matrix and a determinant. What is the difference? A determinant having a value, or a determinant has a value, but a matrix don't have a value. So this is the main difference. And what are the similarities? There are lots of similarities. You will get the structure, rows and columns, etc. as in the determinant. You will get the same thing in the matrices also. And then another thing is some operations are almost same in determinants and also in matrices. Now let us first see what is the definition of a matrix. See, I have already written here a matrix of order m by n. Here I am first mentioning the order. The order of a determinant is already discussed in my video of the determinant, so I am coming to that point. So this is the definition. A matrix of order m by n is an arrangement. See, in the definition the word is there. This is the arrangement of mn numbers. See here another thing, if the order of the matrix is m by n, then how many elements or numbers will be there? M into n. For example, if order is 2, then how many numbers will be there? There will be 3 into 2, 6 numbers. So a matrix of order m by n is an arrangement of mn numbers in the form of m horizontal lines. See, what is the order? M by n. So there will be m horizontal lines which are called the rows of the matrix, and n vertical lines which are called columns of the matrix. So this is the definition. That is, in the definition itself it is given that a matrix is an arrangement of some numbers. So a matrix is totally an arrangement, different types of arrangement, but a matrix, as like the determinants, a matrix does not have a value. Second thing is how to represent, how to denote a matrix. These are the two structure by which we denote a matrix. First notation is a square bracket, and another one is the first bracket. That is, by this structure or by this structure we denote a matrix. Then in this structure we have to put some elements or some numbers. And another thing, as you know, there are two types of numbers, real numbers and complex numbers. So the elements of a matrix or determinants may be real numbers, may be complex numbers, but in your class 12 syllabus there are no matrices involving complex elements or complex numbers. So here all the matrices will be involving real numbers only. So this is the definition of a matrix. This is the style of denoting a matrix by a first bracket or by a third bracket. Next thing, how to represent a determinant. For example, let us take a matrix of order say 3 by 2. This is the order of the matrix 3 by 2. That is, there will be see, if the order is m by n, then number of rows will be m. So here this will be the number of rows and 2 will be the number of columns. So there will be 3 into 2, 6 elements. 6 elements or involving 6 numbers. This is the structure. What is the order? 3 by 2. that is there will be 3 rows, 3 horizontal lines and 2 columns. So first write say this is A1, A2, first row complete, then B1, B2, second row complete, C1, C2, third row complete. So how many rows are there? This one, first row denoted by R1, second row, third row. Then the counting of columns will be from left side to right side. This is first column, this is second column, as there are number of rows 3, columns 2, so this is the order of the matrix 3 by 2. So this is the representation, and the general form of representation of a matrix is, say I am this representing this matrix in its general form. Let us denote this matrix by A. Now see this element A1, the position of this element is the intersecting point of first row and first column, so it is written as A11. This concept already discussed in my determinant video. Second element, this one lies at the intersecting point of first row and second column. This is written as first row, second column, A12. First suffix indicates the number of row and the second suffix indicates the number of columns. So this one will be A21. See, it is written 21. Second row, see this position, it is second row and first column intersecting point. This one A22. This position A22, second row, second column. This one, third row, first column. So it will be written as third row, first column, A31, A31. This is third row, second column. It will be denoted by A32. Completes the order of the matrix is 3 by 2, 3 rows, 2 columns. Next, if the order of the matrix is m by n, that is the total structure in the most general form, the matrix A is written as A11, A12, A13 ... A1m. Sorry, A1n, A21, A22, A23, A2n ... The last one AM1, AM2, AM3, AM3 ... AMN. See here, how many rows are there? As in this structure I have discussed what is the meaning of these indices. The first suffix indicates the number of row of this element and the second suffix indicates the number of column of this element. So here see this one, here the first suffix is 1, this is first row, this is second row, and so on continuously it is increased up to the number m. So how many rows are there? 1, 2, 3, 4 up to m. That is, in this matrix there are m rows. And as you know, I have discussed here, in all the elements second suffix indicates the number of columns of this element. So here for this element the column number is 1, here the column number is 2, here the column number is 3, and so on. In the last element it is n, that is the last column is nth column. So there are n columns. So in total the order of the matrix is there are m rows and n columns. The order of the matrix is m by n. So this is the most general form of a matrix. It is in short, there is a short way to represent this matrix. This matrix is in short form represent as Aij. Ij, I indicates the number of rows and J indicates the number of columns. For this matrix, what is the number of rows? There are m rows. So what will be the value of m? I equal to 1, 2, 3 ... m. And what is the number of columns? Number of columns is n. So what will be values of j? J will be 1, 2, 3 up to n. This is the shortest form to represent any matrix. Either it is of 2 by 2, 3 by 4, 4 by 4, whatever the order is, you can represent a matrix in this way. So this is the general form. This is the definition or the first concept of a matrix. What is a matrix, how to represent a matrix, and what is the general form of a matrix. Next, let us see how many different types of matrices are there. There are varieties types of matrices. Let us see one by one. The first one is types of matrices. Types of matrices. The first one is a rectangular matrix. Here another simple thing. See, the chapter name is written as matrices. Here I am writing a rectangular matrix. What is the difference between two? Matrices is a plural form of a matrix. Is that clear? Matrix means singular number. Whenever you are mentioning one matrix, you have to write matrix, and whenever it is plural form, then we write matrices. So what is a rectangular matrix? Order of a matrix is clear. If in a matrix there are m rows and n columns, then the order of the matrix will be m by n. For example, if there are 3 rows 2 columns, then order of the matrix will be 3 by 2. Rectangular matrix means number of rows and number of columns are not equal. If in a matrix number of rows and number of columns are not equal, I am writing in short, number of rows not equal to number of columns. For example, say A1, B1, C1, A2, B2, C2. What is the order of this matrix? There are 2 rows by how many columns? 3 columns. So this is a 2 by 3 matrix. This is the order of the matrix. What is the order of the matrix? 2 by 3. What is the number of rows? There are 2 rows and 3 columns. Obviously these are unequal, so this is a rectangular matrix. So for a definition, you can say that a matrix in whose number of rows and number of columns are not equal, it is called a rectangular matrix. Next, let us see the second one. As rectangular concept is there, so we can consider square matrix also. Rectangular matrix, see, as in this form, number of rows and columns are not same. So if you close these elements by drawing a quadrilateral, then quadrilateral will be like a rectangle. That's why this form is called rectangular matrix. As order of a matrix is m by n or 2 by 3, 4 by 4, so the second one is a square matrix. Square matrix. Square matrix means is what? If in a matrix number of rows equal to number of columns. If in a matrix, if the number of rows equal to number of columns, then the matrix is called a square matrix. For example, let us consider a matrix like this. Say the elements are A1, B1, C1, A2, B2, C2, A3, B3, C3. Now let us see the order of the matrix. How many rows are there? 3 rows. How many columns are there? 3 columns. So it is 3 by 3. See here, this is the order of the matrix. This indicates that in this matrix, how many rows are there? 3 rows are there, 3 columns are there. As the number of rows equal to number of columns, so this is called a square matrix. Very simple, these things. Just you have to memorize the very simple differences. Rectangular matrix means number of rows not equal to number of columns. A square matrix means number of rows equal to number of columns. So another thing here, square matrix will be of different orders. For example, this is a square matrix of order 3 by 3. Similarly, there may be a square matrix of order 2 by 2. See this one, A, B, C, D. What is the order of this matrix? 2 row, 2 columns. So it is of order 2 by 2. Another one, we can consider a large one also. Say A1, B1, C1, D1, A2, B2, C2, D2, A3, B3, C3, D3, A4, B4, C4, D4. Now see, how many rows are there? 4. How many columns? 4. So this is a 4 by 4 matrix. As long as in a matrix rows and number of rows and columns are equal, so it is a square matrix. Next we have the third type, a simple row matrix and a column matrix. Third one is a row matrix. See the name of the matrix is row matrix. Here you just remember that in a matrix, if number of row equal to 1, clear, if there is a matrix such that in that matrix number of row equal to 1, that matrix is called a row matrix only. So what will be the structure of a row matrix? A single row is there. So I am writing the elements like A1, B1, C1, D1, E1. This is a matrix also, as it is in the form of a matrix. Now see how many rows are there? 1 into how many columns? Each element here represent a column. So how many columns are there? 5. So this is the order of the matrix, 1 by 5. But as the number of row equal to exactly 1, this matrix is called a row matrix. Clear? This may be of another type also, say 2, 3. So what is the order of the matrix? It is first row, that is only 1 row and 2 column, 1 by 2. Here also number of row equal to 1, so it is also a row matrix. Now what is the next one is column matrix. As a row matrix means in a matrix number of row equal to 1, so the number 4 is a column matrix. As in a row matrix, if in a matrix number of column equal to 1, then the matrix is called a column matrix. For example, let us take this matrix X, Y, Z, P. Now see how many horizontal lines you can draw here. 1, 2, 3, 4. So the number of rows 4. How many vertical line we can draw? 1. This is the order of the matrix, 4 by 1. As the number of column is 1, this is a column matrix. That is, what is the definition? If in a matrix number of column is exactly 1, then the matrix is called a column matrix. The next one, the very important one, zero matrix. Number 5. The fifth type of matrix is a zero matrix. It is also called a null matrix. Zero matrix or null matrix means it is a matrix of any order. It is a matrix of any order having all the elements 0. That is, elements of the matrix, all the elements are 0. Then the matrix is called a null matrix, but it may be of any order. Clear? There may be different types of zero matrices. For example, so what is the main thing of a zero matrix? All elements are 0. So this is the definition. If in a matrix all the elements are 0, this matrix is called a zero matrix. Say for example, you can take this one 0, 0, 0, 0, 0, 0. What is the order of the matrix? See here, there are 1, 2, 3 rows, 2 columns. This is of order 3 by 2. Let us take another one, 0, 0, 0, 0, 0, 0, 0, 0, 0. This is of order 3 by 3. Now see, as I have defined earlier, this is a square matrix, this is a rectangular matrix, but both are zero matrix. This is a square matrix, this is a rectangular matrix. As here number of rows and number of columns are unequal, so it is a rectangular matrix, but this is a square matrix. So both are zero matrices. So what is the difference between these two zero matrices? Only because of the order these two zero matrices are not same. Clear? both are zero matrices, but they are not same. But in our simple arithmetic, see, for example, the number 70 or the number 101, here a 0 is there, here a 0 is there, these two 0 same thing, same digit, they both these 0 represent the same digit. But here this is a 0 matrix, this is also a 0 matrix, but these two 0 matrices are not same because of their orders. As their orders are not same, so they both are 0 matrices, but they are not equal. Clear? The next thing is, now let us discuss the next type of a matrix, diagonal matrix. So number 6 is a diagonal matrix. Here you remember one thing, it must be a diagonal matrix is defined only for a square matrix. That is, a matrix is a diagonal matrix only if it is a square matrix. If a matrix is not a square matrix, that is, in another way you can say that a rectangular matrix cannot be a diagonal matrix. So to be a diagonal matrix, a matrix must be a square matrix first. Now what is diagonal matrix? Before that, let us take a square matrix. It is of order 3 by 3. In your syllabus only 3 by 3 matrices are there, 2 by 2 and 3 by 3. Let us take a square matrix of order 3 by 3. Now what is a diagonal matrix? So I am not writing the elements, just indicating the position of the elements. 9 elements are there, 3 into 3, 9 elements. Now see, it is in the form of a square. It is in the form of a square. Here we can draw two diagonals. As you consider this, if you consider this as a square, then we can draw two diagonals. As we know that in a square there are two diagonals, but in the study of matrices and determinants, there are frequently you will get the diagonal of the determinant or the diagonal of the matrix, but in every cases you remember that this diagonal is called prime diagonal or leading diagonal. Clear? And the second one, that is of no use actually, this diagonal is called secondary diagonal. So you remember this, in a rectangular matrix or in a determinant, there are, you can consider two diagonals in a square matrix or in a determinant, but whenever a simply diagonal word is used, you remember that means that diagonal means the prime diagonal, that is this diagonal, and there are no use of secondary diagonal. This one also called the leading diagonal. Now what is diagonal matrix? So in a matrix, in a square matrix, these elements are called diagonal elements, as these elements lies in the prime diagonal or the leading diagonal. Clear? So in a square matrix, all the elements lying in the diagonal, that is the prime diagonal, are called diagonal elements. Now what is a diagonal matrix? Diagonal matrix means all the diagonals elements. First let me write an example. So it is 2 0 0, then says 0 5 0 0 0 minus 3. See the structure of this square matrix, it is of order 3 by 3. These are the diagonal elements, as this one is the prime diagonal or the leading diagonal of the matrix. And the important thing is that here only the diagonal elements are non-zero. but all other elements are 0. See, all non-diagonal elements, here 3 elements, here 3 elements, all are 0 elements, but only the diagonal elements are non-zero. This type of matrices are called diagonal matrix. So what is the condition for a diagonal matrix? All diagonal elements are non-zero and all non-diagonal elements are 0. This is the definition of a diagonal matrix. Before that, diagonal matrix, a matrix to be a diagonal matrix, the necessary condition is that the matrix must be a square matrix. Then if all the diagonal elements are non-zero and all non-diagonal elements are 0, then the matrix is called a diagonal matrix. Then after diagonal matrix, then the second thing is that the next type of the matrix is scalar matrix. Scalar matrix. Here also, to be a scalar matrix, the matrix must be a square matrix. Now see the difference between a diagonal matrix and a 2, 5, minus 3. This was the diagonal matrix. Now see, you can consider a diagonal matrix like this: 2, 0, 0, 0, 2, 0, 0, 0, 2. So what is the difference between these two matrices? It is a diagonal matrix, it is also a diagonal matrix, but the difference is that here all the diagonal elements are non-zero, but they are not equal, they are different elements. Here all the diagonal elements are equal. This is a scalar matrix. This is a scalar matrix. So scalar matrix, first is square matrix, then we can define diagonal matrix, then from a diagonal matrix we can define a scalar matrix. Then the third one is number 8 type. It is a unit matrix. It is a unit matrix. And these three, diagonal, scalar, unit, all are connected. Now see, I am writing another matrix here, taking the elements like this: 0, 0, 1. Now see the differences between three matrices. All the matrices are of same order: 3 by 3, 3 by 3, 3 by 3. What is the differences? In the first matrix, all diagonal elements are non-zero, non-diagonal elements are 0, and these elements are not equal. Here same thing, all non-diagonal elements are 0 and diagonal elements are non-zero but equal. In this case, this is called a scalar matrix. Here same thing, all diagonal elements are non-zero and non-diagonal elements are 0, but all diagonal elements are particularly 1. That's why this is called unit matrix or an identity matrix. Unit matrix or identity matrix. Clear? So identity matrix may be of different types depending on their orders. For example, this is a unit matrix of order 3. So this is written as I3, identity matrix of order 3. What is the elements? 1, 0, 0, 0, 1, 0, 0, 0, 1. So what will be I2? I2 will be I2, as it is, it denotes the identity matrix of order 3. I2 denotes identity matrix of order 2, that is the elements will be 1, 0, 0, 1. So these are first different types of matrices. In the next part, after defining some operations on a matrix, there are some different more types of matrices. Before that, before defining say symmetric matrix, skew symmetric matrix, singular matrix, orthogonal matrices, before defining this we must have to know some operations on matrices. Up to this, these are the basic types of matrices and the definition of matrix is defined here. So hope the definition of a matrix, what is a matrix, what are the different types of various matrices, what is order of a matrix, what is row and column, the next one is what is diagonal of a matrix, all that for this part only. In the next part I will discuss some operations and some more types of matrices. Hope this is clear, all these things are clear to you. Thank you very much.